Hello folks, this is your 2023 May-June paper 1-3 and the question number is 34. This is again concerned with the chapter current electricity. It says a battery with internal resistance, so this thing has got internal resistance, let me use it as R, is connected to a parallel arrangement of two resistors here and a switch, yes, shown. Initially switch S is open, open. What happens to the voltmeter and ammeter readings when switch S is closed? So if I close this, what happens to these two readings? One thing that we have to remember here is this measures the current flowing here. I measures the current flowing in this path. This is I and I. And V measures the terminal potential difference because it measures the PD across the two terminals of the source. So it measures the outer PD, terminal PD. So our I should be is equal to EMF by total resistance in the circuit. So let me say the resistance of this arrangement is R, and this is small r. So our I should be equal to E by R plus R. R is the total outer resistance, and then small r is the inner resistance. So I should be like this. Now, if I close this switch, this resistance also comes into existence. Initially it was useless, now it comes into existence. So that means there are two resistors in parallel, which means the overall R decreases because in parallel the total R is less than that of the initial single resistance. So R decreases. Now if R decreases, this I increases. So let me say, so if I close the switch, yes closed means two resistors in parallel, which means R decreases, and if R decreases, then I should increase. So I increase means our ammeter reading shows increase. Increase means A okay, C okay, B and D not okay. Now this V here, so this V measures the external PD here. So this external PD is obtained by the voltage division of E. So this external PD V is equal to voltage divided form of E. So it should be equal to R by R plus R then E, because it is measured across this external resistance. So this A is just a shortcut here. It is some sort of short circuit here because A has got no resistance. So that's why V is measured across R. The total resistance is R plus R. So V should be like this. So now if we close the switch, this R decreases as we have already stated. So when R decreases, what happens is, so yes closed, once again, yes closed, two rays in parallel, so this whole R should decrease. Now if R decreases here, in the denominator R will decrease 100%, but in the numerator R will decrease less. In the numerator R decreases rapidly or fully, but in the denominator R decreases less because it's because of this thing. So that's why this whole thing should decrease. So that means V should decrease as a whole, which means that our correct choice is choice number A, and choice number C is also incorrect. So A is the correct answer.